Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with a very interesting topic of the chapter Atomic Structure. The topic is photoelectric effect. Now in order to study this phenomena, several experiments were done by Hertz. And he found that whenever a beam of light strikes a metal surface, the electrons are ejected. And it was also found that there is no time lag. As the beam of light is striking, immediately the electrons will be ejected and a current will be set up in the circuit. It was also noticed that the number of electrons which are ejected is proportional to light intensity. How many photons are there? The number of photons will definitely decide how many electrons are getting ejected. But for this phenomena to happen, a minimum frequency is required below which there is no chance of any electron getting ejected from the surface. This minimum frequency is termed as the threshold frequency. If the frequency is more than the threshold frequency, the electrons which got ejected will gain kinetic energy and they can start moving fast. It is like a situation, students, like when you want to buy certain things, let's say some stationery, it costs only 50 rupees, but you take 100 rupees with you. After buying that stationery, from 100 rupees, you are left with some money. With that money, you can buy certain things of your own choice. It is the same story here. Since the frequency is more than the threshold frequency, the electrons will be gaining kinetic energy at the expense of that extra energy. So if this is the total energy, out of it a certain part will be used for ejecting the electrons. The left out energy will provide kinetic energy to the electrons. For example, the threshold frequency for potassium is 5 into 10 to the power 14 Hertz. Whatever may be the intensity of the light being used, if the frequency does not match, if it is less than this, no electron emission is observed. There were certain experiments done with potassium, as we know that red color is having a very long wavelength. Wavelength is high, therefore frequency is low compared to the other colors of the spectrum. So when red light was used, no photo emission was observed. Whereas as soon as they started using another color wavelengths like yellow light, emissions were seen. So frequency is the important thing to start the emission, not the intensity. Frequency is the key factor here. Now the minimum energy which is required to eject the electron is known as work function. We can denote work function by W naught. W naught is equal to h nu naught. H is Planck's constant. Nu naught is the threshold frequency. So h into nu naught gives W naught. So now the question arises, after the electrons are ejected, how much kinetic energy they can gain? That can be calculated from two things. One is h nu. H nu is the energy which is incident on the metal surface. H nu naught is the work function. That is the minimum energy required for ejecting the electron. So out of the total energy bundle, if we subtract the amount of energy which is required for ejecting out the electrons, if we remove that much of energy whatever is left out, that will impart kinetic energy to the ejected electrons. So h nu will be equal to h nu naught plus half mv square. This half mv square is the kinetic energy factor. In this, m is the mass of electron, v is the velocity with which it can move. More intense the beam, larger number of photons. So the number of electrons which are ejected will be more. If we take a weaker intensity of light, number of electrons ejected will be less. When the intensity is very high, number of electrons ejected will be more. Hence, the current which we will get will be more. So this is all about photoelectric effect. Thanks for watching the video. Kindly subscribe to my channel so as to stay updated with the latest content. Thank you all.